remember? And didn't we write an equation? All right, I need somebody to tell me what that equation is, because I did not. Right? Thank you, Xander. Are all the phones up here where they're supposed to be? Make sure they are, because if I count they're not all there, we're going to have trouble in River City. All right, what did we come up with when we wrote our equation?
Y equals 0.4x minus 793.3.
Okay, so that was our prediction equation. And then we actually applied it to a data point that plugged in 2002. And we didn't get exactly what was in the data table, but we got something relatively close. And we talked about that we're not going to get exactly what's there because no data set that's actually data gathered is going to lie in a perfectly straight line. That just doesn't happen. But this line that we came up with, using the first 2 points, is an approximation. Now, what if we did the same problem over again, but instead of using the first 2 points, we use the second, points 2 and 3. Could we get an equation of a line using those 2 points? Yes. It wouldn't be that exactly. We'd get another one, right? The moral of the story is there are lots of different lines that we could come up with depending on which points we picked. Your calculator will find the very best line. So that's what we're going to do now. We're going to do what's called linear regression. Have you done that before? Maybe? Maybe not? Okay, so here's lots of different wacky things can happen. Everybody needs a grapher. Get it out. If you don't have one, you're going to have to rent one for me, and then your name goes on the board and you owe me 50 cents. Gotta have a calculator. You cannot learn how to do this without pressing the buttons. Joe Funk?
Yeah.
You don't have a calculator?
It's dead.
Okay, a dead calculator is like no calculator, folks. We have to have a functioning calculator. Give me your lanyard. All right, who else? Everybody's got one? You have wonderful human beings, except for Joe. Okay. All right. So here's what we're going to do. We're going to put in these data points. So I want you to press stat. See your stat button right here? You're pointing. Button that says stat. Press it. It gives you a menu, just like all the buttons do. It gives you a menu. We are going to put data into our calculator. So that is the edit. When you edit, you're putting the data in or changing the data that's already in there. Okay, so press edit. Did it come up with some columns? Probably labeled, unless somebody screwed with your calculator, L1, L2, L3, whatever, right? Does anybody already have data in there? Okay, here's what, so all of you listen, because you're gonna put some in the rest, you're gonna have it in there too, so pay attention how to do this. So look at where it is. Is it in L1, L2, whatever, wherever it is? You see where it is? Because you're gonna need to know that. Okay, so now go back to your stat menu. And option 4 for me, is it for you? It says clear list. Okay, press that. Oops, I didn't press clear list. Press clear list. And then type in the columns you need to clear. So if you look above the 1 key, above 1, it says L1. So if you need to clear L1, press second L1 or second 1. Then put a comma, and you have a button that's a comma. Look where my finger is. See that button? It's got a comma. And then do second L2. That's all I need to clear. And press enter. It'll say done. And now when you go back to stat, edit, those columns should be clear. Now you can also type over numbers. So if you don't want to take the time to clear, you can, like whatever number was your first number in there, you can type a new one and it will replace the old one. The problem with that is if the data sets aren't the same size, you may have some extra crap down there that you don't want. So I like to just clear it all out and start fresh every time. But you can type over. okay? Now, everybody's got a clear L1 and L2. You're gonna type in your X values in L1 and your Y values in L2. Now, this is only gonna work if you keep them lined up, so make sure you're keeping them in order. So L1 is 1998. Got them all in? Now, most of you have the newer calculators, so it's a little bit different. It's actually so much better for you, but it's a little bit different. If you have an older calculator, well, actually, everybody is gonna proceed this way. Everybody got your data points in? Okay, go ahead and second quit. So second quit. And then go back to your stat menu and click over to calc. Remember, edit is where you put data in. Calc is where you do stuff with it. So now you've got a ton of different options. It goes on and on. We're going to do linear regression. So we're going to click down to number 4. Linear, for me it's 4. The one that says linreg. And press enter. Now this is where things get a little different. Let me see the new calculator. What does it say? Okay, if you have a newer calculator, okay, you're gonna click all the way down to where it says calculate and press enter, okay? If you have an older calculator, as soon as you hit linreg, you're just gonna hit enter and it's gonna do it for you. And we're gonna talk about how the new guys have it made in the shade, because that's old guys, but it's okay. When we did that, did everybody get an A value of like 0.374 and a B value of -741, and then there's some other stuff we'll talk about? But notice that the calculator tells you the equation I come up with is going to be of this form, y equals ax plus b. The calculator says that. So your A is 0.37428574143, and we are not rounding off. We are not rounding off. Now you guys, with the new calculators, you have a store capability that I don't think the old ones have. At least if they do, I don't know how to do it, just what the new ones do. So I have to write down all these decimal places. That's my X. And then my B is negative 741.9085714. Now I want you to compare this. Remember, this is the line of best fit. So for all of these data points, the best line, not perfect, but the best line is this one right here. So you see how close we came with our approximation? Are our slopes pretty close? Yeah. Our y-intercepts are off a little bit, but remember, that's a very big number. So relatively speaking, those aren't too far off, but this is the very best line that we could come up with. Okay, now we're gonna see how all this fits together. So, first thing I want you to do is we're going to now plot our data points. So we're going to actually physically on the calculator plot our data points. So, first thing, go to window. Remember, the window is where you establish the size of the screen you're looking at. Look at your X values, you guys. What are our X values? They range from 1998 to 2003. So I'm gonna make my X-min a little bit lower than 1998. So maybe I'll do 1995. And then my X-max might be 2006. Those are my X's. Now, what about Y-min? What's our Y-min gonna be? Maybe 5.5? And our Y-max is maybe 8.1? I'm just giving myself a little wiggle room on both sides. Okay? So these are the points I'm going to plot, so I have to make sure my window is the right size. All right? Now, above Y, so second quit, let's get out of there. Above the Y equals button, you see where it says stat plot? We're gonna plot our stats, okay? So second stat plot. Right now, all your plots are probably off. Normally we always want them off. Unless we're plotting statistics, we want them off. But we're gonna plot statistics, so we wanna turn it on. So plot 1, we're gonna turn it on. So see if you can figure out how to turn it on. You wanna turn on plot 1. Okay, now somewhere you should have your X and Y lists, L1, L2. Those are the lists you're graphing. Does that make sense to you? If it doesn't say X, L1, then make it L1 because we're graphing. Our X's are L1 and our Y's are L2. All right, don't worry about the rest of that stuff. We'll see what happens. Press graph. Did you get some dots? Press graph. Just press graph, guys. Everybody got some dots? They look pretty linear, don't they? They do, which is good as we go to linear equations. Some data points, when you plot them, will come out with more of a curve. So then, depending on the type of curve, we won't do a linear regression, we'll maybe do a quadratic regression. We'll write a parabola instead. On the calculator, that's no harder. By hand, it's a lot harder. All right, so now we're gonna see how good our equation is. So now I want you to go to Y equals. And if you already have an equation in there, I want you to clear it out. And I want you to type in this equation right here. This is our equation. So we already have plotted our data points. Now we're gonna graph our line and see how well it fits those data points. And hit graph. So now you should still have your dots, but you also have a line now. It is important in the AP curriculum that you not round anything off to the very end of the problem, okay? Now we're gonna talk a minute. I don't have a new calculator. Maybe if I do enough rentals, I'll be able to afford to buy one, but I don't have a new one, so I haven't played with it a lot. But you guys are gonna figure this out with the new calculators. You don't have to retype this in. It will store that equation for you, and it will graph it and typing it in. But interestingly enough, when I went to my training this summer, they kept saying, don't round off, don't round off. Well, when I was practicing all this, I got lazy, and I said, well, you know, it can't make that much difference. You would be amazed. When I rounded off this equation to like 3 decimal places, it gave me an equation that was way different. It did not fit the data points nearly as well as this one does. So, moral of the story, do not round off, okay, till the end. I mean, eventually if you have to put something in the answer blank, you may need to round off. But otherwise, let's not round off. Okay, so I want you guys with new calculators, I want you to go back to, let's see, stat calc and linear regression and press enter. So go back to your calc menu, choose linear regression and press enter. Do you see how one of your options, we went down to calculate, but you see what option's right above that? Store lin reg. Guess what that means? Store reg equation. That will store your equation. So I think what you do, can I borrow your calculator? And again, you guys are gonna have to play around with this, but I think then what you do is you choose that, go down to store regression equation. Then I think you hit vars, your variable button, which is right here, it says vars. See it? And I think you go over to Y vars, hit enter, and enter. Did it work? Did you have that equation in there? I don't know if it worked or not. Let's hit graph and see what happens. I gotta take that out. Well, I don't know. Play with it a little bit. I think we try one more time. You guys with the new calculators. Now, if you can't figure it out, it's no big deal. You'll just do what we do with the old calculators, right? That will never let you down. This is just kind of a little shortcut. Maybe Google it and figure out somebody, I'm sure, has something with it. Yeah, I don't know. I can't get it to graph it. So I know it has something to do with that Y bars thing. Oh, there it is. Yeah, that's it. So take out the old equation. If you had the old equation in there, go ahead and clear it out. If you type that in, go ahead and clear it out. Then go back to stat, calc, linear regression. Go ahead and calculate it so that it's done the work. Then go back in, stat, calc, linear regression, and then store vars, y variables, enter graph. Ah, I did it the first time and now it's not working. Oh well, I don't know, we don't have time to waste on it. Google it if you want, it's a little shortcut for you to not have to retype all this in, okay? I'm gonna have to always retype it in because this is the only calculator I have. But if you can figure it out on yours, the new calculators will allow you to do that. I did it, I just once. All right, let's try the next one. So we just superimposed the equation on the scatter plot of the data. All right, let's try the next problem. This is Hastings Smith, plans to invest, okay. What are the possible values of X? It's to invest an equation. Okay, so this is not a stat plot problem, this is a new kind of problem, so let's see. She's got, okay, what are the possible values of X? So X is the amount of money at 5%. What are the possible values of X? So in other words, what is the domain of this problem? What are the possible values of x? What do you think? Well, can x be negative 50? Can x be a billion? All right, so somewhere between negative 50 and a billion. Can you narrow it down any more? The maximum is 18,000, right? What's the minimum? Zero. Zero. So your domain, your possible values of x are 0 to 18,000? I don't know if we're gonna ultimately end up graphing this thing, but if we are, what's this? X min, X max, right, on my window. That's X min, X max. Right now, your window is totally screwed up, so whatever you graph after this, you're gonna have to fix that. But for this problem, that would be my domain. So that's the first part of the problem. If she invests X dollars at 5%, write an equation that describes the total interest earned in 1 year. So now we're gonna write an equation for the total interest that she earns. So she's got 2 pots of money, right? She's got some money at 5%, and then she's got some money at 8%. How much is in that pot? Josie?
18,000 minus x.
Yep. Would everybody agree with that? How do we calculate simple interest? This isn't all that compound crazy stuff. This is simple interest. How do we calculate that? It's annual interest. Anybody remember a little formula from first year algebra? I equals PRT? What's P stand for? Principal. And that, what's principal? The money you put in, right? So if I walk down to the bank with $100, that's my principal. R stands for the interest rate, always entered as a decimal, and T, of course, is time. Now, for our problem, time is 1 year. So, how much money is her account, is her 5% account, or how much interest is her 5% account earning? Interest equals the principal, how much does she have in there? X, times the rate, which is 0.05, times the time, which is 1. So that's how much she's making on her 5% account. How much is she making on her 8% account? Well, principal is 18,000 minus X. Interest is 0.08, and the time is still 1. We're doing this for 1 year. So my job was to write an equation, so I can probably clean this up a little bit, maybe. This is 0.05x. What's 18,000 times 0.08? $1,440 minus 0.08x. I just distributed here. So negative 0.03x plus 1440. Is that okay with everybody? Writing a linear model, writing a linear equation for the how much did she invest in each account if the total interest is $1,050? What do I do with that? How much did she invest? What are these, in other words? If I know my total interest is $1,050. Sabrina?
Substitute 1,050 for Y.
We're gonna plug it in right here for y, because y is the interest, right? So 1,050 equals negative 0.03x plus 1440. I don't think I need to graph this to solve it, it seems pretty easy, but I will use my calculator to help me with the math. Did you get 13,000? Can someone nod or give me a sign of life here? Okay, good. So we got 13,000 here, which means at 8%, she invested 5,000? Right?
Yeah.
Done, that was easy enough, didn't need a calculator, but we wrote a linear model. This section is all about lines, and we wrote a linear model from the situation. In the last one, we wrote a linear model from a set of data points. All right, P4, due Monday. Now, we're gonna look at some quadratics real quick. They are important. They are important, so we gotta review some of the ideas. Anybody know what the zero product property is? I hear a lot of mumbling, jumbling. Somebody say it louder to me. What is the zero product property? If A times B is zero, so if the product is zero, then what do we know for absolute sure? Either A is zero, B is zero, or both are zero, right? That's the zero product property. Mrs. Poor, why do we even talk about that? It's so obvious. Yep, remember that whole completion deal, that whole thing, every base has to be covered in mathematics. You use this property all the time. When you factor something, what's the next step after this? You set them both equal to zero, right? You're using the zero product property every time. Quadratic equation. What is a quadratic equation? This is a linear equation, right? Or your calculator says ax plus b. The letter used doesn't matter. That's a linear equation. What's a quadratic look like? Y equals ax squared plus bx plus c. The only stipulation is, of course, a cannot be zero, because if a were zero, you wouldn't be quadratic, you would be linear, right? That's it. What's the quadratic formula? This is a quadratic equation. Actually, this is a quadratic function. This is the general form of a quadratic. What's the quadratic formula, which is what we use sometimes to solve equations that look like this? X equals
Negative b plus or minus the square root b squared minus 4x all over z.
If you don't know that, get it learned. Okay, that's just an absolute expectation of everybody everywhere in the world that's at this level of your math studies. Okay, this guy right here is really important. B squared minus 4ac. Now, not the radical. The radical is part of the formula. The thing under the radical, that b squared minus 4ac, is called the discriminant. Don't get that word confused with determinant. If you talked about matrices last year, you talked about the determinant. This is the discriminant. Why is that important? Well, tell me what happens if b squared minus 4ac is negative. Tell me what happens when I solve my equation if that number right there happens to be negative. Then my roots are going to be imaginary. I'm going to get two imaginary roots, because that's going to produce an I, and my answers are gonna have i's. What happens if b squared minus 4ac is 0? Think about that for a minute. What happens if that stuff right there turns out to be 0? What happens? Well, quadratic equations are supposed to have two answers. The fundamental theorem of algebra, actually a corollary to the fundamental theorem of algebra, says if the degree is 2, it's going to have two answers. But if that discriminant is 0, you end up with just one answer. Technically there's two, but because negative b plus 0 is the same as negative b minus 0, you just get one, and it's rational. So you get one rational root. You get a number, whatever negative b over 2a is, that's what you get. So negative 3/5. One rational root. Now, if b squared minus 4ac is positive, there are a couple of things, different things that can happen. You can be b squared minus 4ac is a perfect square. That's a different result than if b squared minus 4ac is not a perfect square. What is the difference? Remember, we're talking about this guy right here. What happens if that's a perfect square? Think about it. 25. What's going to happen if that works out to be 25? Are we going to get two answers? Yeah. Are they going to have radicals in them?
No.
No, aren't they going to be things like 6 plus or minus 5 over 4, something like that? So if that number happens to be a perfect square, we're going to get two rational roots. 2 7/5. What if it's not a perfect square though? What if this is like 17? Am I still going to get two answers?
Yes.
But what are they going to look like? Irrational. They're going to look like negative 6 plus or minus the square root of 17 over 5. So we get two irrational roots. So the discriminant tells us the number and nature of our solutions. How many answers am I going to get? What kind of answers am I going to get? That's what the discriminant does. All right, now we're going to solve on our calculators, and we're solving. So, first thing let's do, just to make our lives easy, go to Zoom 6, and let's just go back to a normal window. All right, let's graph it, see if you can solve it. Please solve this graphically, not another way. I know this one solves a different way, that's okay. We're going to solve it graphically. All right, so you're back to regular Zoom 6, so you can graph normally now. Go to y equals, clear out that old equation, and type in your new one. Did anybody have any difficulty? Did it work for everybody? Nobody got an error of any kind? It was perfect for everybody? Okay, that's great. All right, so I've got this thing graphed. It's nicely a parabola. Where, I'm supposed to be solving it, where are the solutions? I heard somebody say on the line, on the x-axis. These are called the zeros. They are where the curve equals 0. So we're going to find those. So second calc, second trace, choose the 0 option. Are you with me? Have you done this before, probably? So you're gonna do the whole left bound, right bound thing, 1 point at a time. I got negative 0.5 for that one. These are coming out nice. It's rigged, kids. They don't always come out so nice, but for our first example, we're having them come out nice. And I got 2 for the second one. Now, while we're finishing up there, do I need to come around and get everybody jump started here?
How
Everybody
do you
get
get those exact numbers?
Okay, so Mr. Brady says, how do you get those exact numbers? He says, I'm getting close. Kids, we aren't using trace. We aren't tracing. That does not do it exact. So we're using our calc menu. Second, calc 0. Left bound. Right bound. Yes. It's not exact. Okay, so we gotta use our second calc, our calc menu. We're not zooming and tracing and all that stuff. That's what there's no need to do that. Use your calc menu. So, second, we did this yesterday. Second calc, choose 0. That comes out of your calculator. All right, if you finish that one, we're going to do number 3 with our calculator, but we're going to solve with intersections. We did this yesterday or another day, someday. So we're going to put in 2 equations in our calculator, and we're going to figure out where they cross. You do exactly the same series of steps, except you don't choose second calc 0, you choose second calc intersect, right? So let's put these equations in. Uh, 3x cubed, that was x cubed, right? Yep, 3x cubed. Everybody know how to get x cubed in? Little arrow or caret thing. Okay. And 12x. Now, I went ahead and used my standard window. Does your picture bother you at all? When you get a picture, does it bother you at all? Is it kind of hard to tell? I see one point of intersection very clearly, but is it kind of hard to tell where the other ones are? Or for you? For me it is. So I'm going to make some window adjustments. I'm going to adjust my window and try to open up that picture a little bit so I can see a better view. So remember, you are looking for where they intersect. So if you can tell from what you have, you're good to go. But if you're, it's like, oh, it's not too clear, then fix your picture. So adjust your window. Press window and change your X's and Y's. And keep going back to the graph and seeing if it helps. Same way you found the zeros, only choose second calc intersect. Okay, so again, pick whatever window you want. If you're still struggling a little bit, for my X's, I went from -4 to 4, and for my Y's, I went from -30 to 30. And now I have a picture that is very opened up so I can see what's going on. There's my cube. And then I have this line that looks like this. So I can clearly see my points of intersection. That is not mandatory. That doesn't matter. You don't have to do that. I did it so I could really clearly see what was happening. So second calc intersect, so that's option 5. You're gonna set a left and a right bound, just like you did before. So pick the point you wanna surround. If you wanna surround this guy, then your left bound, use your arrow buttons. Your left bound has to be over here somewhere. That's gonna be your left bound. And then your right bound, which is second curve, is gonna have to be, oh, actually, that was the line, sorry, that was here. This is going to be here. And that point is -2, -20. Is that what you got? -2, -24? Remember, we're solving for x, so x is -2. We don't care about the -24 right now. That one's obviously 0. I can tell from the equations that one's 0. And I bet that one's positive too, but let's double check. Second calc intersect. First curve. Second curve. And yes. And yep, that one's 2.
Positive 2, positive 24?
Yep.
What is that?
For this one. That's this one. But remember, it's only the x's that I care about when I'm solving an equation. But yeah. We can solve finding the x-intercepts, and we can solve using intersections. You'll decide as you do the problems which one fits for you or which works for you best, but both of them mean second calc, right? That's how we do it. All right, now we're gonna do a little bit of work by hand quickly. So solve by factoring. Oh, we're gonna do the same 2 problems, but we're gonna solve them by hand. So, in the AP world, and again, we're not sure we're even gonna be an AP class, but you're gonna take AP calculus. Some of it's with the calculator, some of it's without. So we have to be able to do problems both ways. So solve by factoring, okay, everybody can do that, right? I do not want to have to spend more than 1 second on this problem. We all know how to do this. Very important skill because it helps us simplify problems in the future. I cannot remember what I got when I did it on my calculator, but did I get -1/2 and 2? I hope, because those are the answers. How about this guy? How are we gonna solve this one by hand? And if you tell me to divide by 3x, I'm going to come back and physically do something. We cannot divide by a variable. Do not divide by a variable. Why not? It might be 0. And you can't divide by 0. So if there's any chance at all that something is 0, don't divide by it. So don't divide by 3x. What are we going to do instead? Set it equal to 0. And then, instead of dividing by the 3x, I can factor it out And that will leave me with x squared minus 4. And what do we know about x squared minus 4? It's the difference of squares. So look at the answers we got. X is 0, 2, or negative 2. There's a perfect example of a problem that's easier done by hand than with the calculator. It's faster by hand. But of course, it's very special and big too. But, good. All right, number 5, extracting square roots. I think that's a crazy way of saying it. What do you think they mean when they say solve by extracting square roots? That's your book's vocabulary. What does that mean? So what do we have? 2x equals plus or minus 5. This is the tricky part. Whenever you take the square root of both sides of an equation, and it's a legitimate thing to do, you're allowed to do it, go ahead and do it. But whenever you do it, it's plus or minus, right? If somebody says x squared equals 9, and you square root, aren't you gonna say x equals plus or minus 3? Every single time. So what are the answers to the problem? Plus or minus 5 halves. Okay. Quick review of completing the square. Anybody remember how that works? Completing the square? We kind of already did it with our circles. Tell me, what do I do? Move the 4 over. We have no room for the 4 because we are going to make this a perfect square. That's the objective. And 4 does not fit. So get rid of it, move it over. Now you have to find the magic number here that is going to make that a perfect square. So it's just like with your circles. Half of 10 squared is, okay. So what's my perfect square then? X plus 5, 29. Now we're going to do that thing. We're going to extract square roots. We're going to take the square root of both sides. So x plus 5 equals plus or minus root 29. And x equals negative 5 plus or minus root 29. There are your 2 answers. Easy peasy. Last problem, B. How are we going to do this one? Okay, the 7's got to go. X squared has, the coefficient on x squared has to be 1. So we need to divide everything by 3. You don't have a choice. Don't try to get crazy and creative because it's not going to work. You got to get rid of it. Fractions better be your friends because we're going to get a bunch of them here. What do we need to do? Take half of 2/3, right? What's half of 2/3? 1/3. And then square it. So what am I adding to both sides? 1/9. This is a perfect square. Believe it or not. What perfect square is it? X minus 1/3. Minus 1/3. You gotta have a minus in there. And it's 1/3 because that's what you squared to get the 1/9, right? equals, okay, let's get a common denominator here, is that 22/9? So x minus a third equals plus or minus root 22 over 3. So x equals 1/3 plus or minus root 22 over 3. You can actually write that together if you want, since they have the same denominator, or you can leave it separately, separate like that. All right, we are not quite done with P5 yet, but when we finish P5, we'll be having a quiz. So next class, is it tomorrow? We will finish P5 and start practicing for a quiz that we'll have in our next class after that, okay? All right, grab your phones and have a great day. You guys with those calculators, play around with them a little bit, see if you can figure that out to save your